all of you to this new video of locus ICSE. We are getting ready for ICSE 2026. Now this is not a topic you should miss in your exams. I know that those who are seeing the video are still very doubtful about this topic. Okay, now this is not at all a difficult topic. You will only tell this at the end of the video. Okay, why? What is locus? What is loci? Loci is nothing, it is the plural of locus. Okay, so the chapter name is locus. In the beginning, first we will understand the concept behind locus. Otherwise, we will not be able to do any sum on locus. Okay, second thing what we are going to do is we are going to do 2 or 3 easy questions, 3 easy questions, and then we are going to take up 4 most important questions, previous year's questions, ICSE questions, which are so important that if you know those 4 questions, you can actually attempt locus in the boards. Okay, so why leave a locus question in the boards? If you keep, if like this, if you keep on leaving questions in the board exams, you will be left with very little choice. Okay, so we will have to know as much as possible, as much as we'll have to try and cover the syllabus. We have to be confident about as many topics as possible for the board exams. Okay, maybe one chapter, one part of a chapter we don't know, that is understandable, but we can't leave one full chapter as a doubtful chapter. So let us see what is locus first. Okay, once we understand what is locus, we'll start with the sums. Watch the video till the end because all the sums I have chosen, they are very, very important for your understanding. Okay, let us start. Firstly, what is locus? Okay, what is this locus? Okay, it is, suddenly we have not done anything like locus before this. This is the first time we are doing it. Locus, you know what it is? It is a path. It's a path. If I say it is a path, it's better. Now locus is, supposing this is path of a line, like the, I have, so path of, so it is a path. The path can be a straight line path, it can be a path can be a straight line path, or it can also be a curved path. It can also be a curve like a circle. Let us see the 3 theorems which we have to know in the chapter locus, because most of the questions are based on this. Along as we do the theorems, you will understand what locus is. Locus of a point at a fixed distance from a fixed point. Fixed point. First, let me draw the fixed point. Locus of a point, so this is the point P which is fixed, of a point which is at a fixed distance from a fixed point. That means this distance, let's say it is 5 centimeter, it remains 5 centimeter no matter where I draw Q, it is 5 centimeter. Okay, 5 and 5 and 5, always 5. Okay, so now this point Q is moving, touching these. This is the path of the point Q. This is the path point Q is taking, and that is what? That is this is the path point Q is taking, and that is called the locus of the point Q. Okay, and what is the shape that it is getting? It is getting a circle. So point Q, locus of a point at a fixed distance from a fixed point is a circle. So the locus is a circle, okay, which is, so if I join all these Q's, I am going to get a circle. Now otherwise also you can understand, if one point is fixed and another point is moving around it at a fixed distance, that means the radius of a circle is always equal, right? So if I am moving around it at a fixed distance, then I will form nothing but a circle. Okay, I am moving, supposing your friend is fixed and you are moving like this around your friend, you are actually forming a circle around your friend. So this is one concept that will be used in this chapter. Okay, so locus of a point at a fixed distance from a fixed point is a circle. Let's come to the second theorem, locus of a point equidistant from 2 intersecting lines. Let me first draw intersecting lines, and this is intersecting lines, okay, and point point equidistant from intersecting lines is the bisector of the angles between them. Now this is one angle, this is the same angle. These two are equal, okay, vertically opposite angles. Bisector of this. Now I want points. If I put a point here, I want it to be equidistant from this and this. Okay, now if you have a line and you have a point, remember if I say this point P, what is the distance of this point from the line if I ask you? Then will you draw it like this to measure the distance? Will you draw it like this or will you draw it like this? Okay, it is the distance. Whenever we measure distance, it is always the 90-degree line. Okay, so here locus of a point equidistant from two given lines means I want a point here which is equidistant from this line also, means I will have to draw a line here and this 90-degree has to be equal to this 90-degree. Okay, because this distance d1 has to be equal to d2. We can clearly prove it because 90, okay, and this is the common side, yes, and this is the common side. And this angle, because I have drawn the angular bisector, when I draw the angular bisector, these two angles are equal, these two are equal. So by, you can say ASA, by ASA we can prove congruence. In that case, d1 is equal to d2. So basically for the angular bisector, this side also we can prove the same, even this side we can prove the same. So the locus of all these points, can you imagine all these points, I can draw this 90-degree anywhere I want and it is going to be equal. Okay, because this is the angular bisector. So what they are saying is locus of the points, so locus of the points which are at equal distances from two straight lines, okay, they are at equal distances from two straight lines, is actually the path of those points is actually the angle, is the angular bisector, is the bisector of the angles, means the angular bisector. Okay, so this is the second theorem. If you have not understood, please go through the video again and again to understand this, because if without understanding you cannot understand any of the sums of this chapter. Okay, now next come to the third theorem. This is also equally important. Actually these two are more important. Locus of a point equidistant from two given points. Now this and this might sound similar, but this is two intersecting lines and this is points. So here we had two lines before this. In the third one we have 2 points. Let's say point A and point B. Locus of the points equidistant from two, if I have a point here, this I tie a rope, okay, I tie a rope, it has to be equal. If I have a point here, here also I tie a rope, these two, here also I tie a rope, these two ropes have to be equal. Okay, similarly another point and these two ropes have to be equal. If I join all these, okay, if I join all these points, you know what I'll get? I will get the perpendicular bisector, means the line which is the locus of these points is going to be the line which is at 90-degree, and also not only at 90-degree, it is going to cut this into half. You can actually prove it by, see, I'll just prove it here. This is, if this is, I've drawn the perpendicular bisector, then, you know, let me join this, then this part is equal to this, okay, this part is 90-degree, okay, and this is equal. By SAS congruence, we can say these two triangles are congruent. By CPCT, this is equal to this, and this you can draw as many as you want, okay. Always this hypotenuse is going to be equal by CPCT of two congruent triangles. So to sum it all, here if you have a point and you have a point, now again all three together, if you have a point and another point is moving around it at a fixed distance, it forms a circle. If you have two intersecting lines and you have a point moving in such a way that it is equidistant from both the lines, then it is the angular bisector. Okay, so this line, the locus, is the angular bisector. And if you have 2 points and you have a point which is always equidistant from these 2 fixed points, then it is the perpendicular bisector of the line joining the 2 points. Okay, so these are the 3 theorems on which the entire chapter is based. So this much for the concept of locus. Let us come to the next part of it. We are going to do few sums. Then you will understand how exactly they ask the questions based on locus. Okay, so first question, describe the locus of a point in a rhombus. So you will have to note these points, locus of a point in a rhombus. So most of the questions you will need to construct. Okay, they will look for constructions, not protractor, but then you will have to use a compass. Now I have drawn a rhombus. Describe the locus of a point in a rhombus. Now the rhombus is A, B, C, D. You must name. Now I have drawn a rhombus which is ABCD, which is equidistant from AB and AC. Okay. Now, what will you do here when no values are given? You take any random, you can take 5 centimeter, 5 centimeter and just make a rhombus, any angle. Okay, any angle is okay. You don't have to think what angle. Any comfortable angle, just make a rhombus if a question comes like this. Now, you want the locus of a point which is equidistant from AB and AD. AB and AD. The point has to go equidistant, means if I draw here, so which theorem? It is the theorem which told us that a point is equidistant if the locus of a point equidistant from 2 given lines is the locus of a point equidistant from 2 given lines is the angular bisector. So what you have to do here is you have to make an arc like this and then take this radius. You have to fix your compass here. You see, note this point. Okay, here you have to fix your compass and you have to pull the pencil end till here. That means you are measuring. Those who don't know how to bisect an angle, I am talking to them. If you know bisection of an angle, not a problem. So you will have to measure. You will have to open the compass and take it till here and measure. Okay, so fixed end here, pencil end here, and you measure like that and don't change that arc. Okay, don't change that arc, don't change the radius. Fix the compass here with that radius. Now make an arc here. Same radius, don't change, make another arc here. Okay, sometimes people also say more than half of this arc. That is also okay. To be on the safer side, I say pull it up till here, pull your pencil end till here. Now join this, okay, and if your sum is correct, if your construction is correct, if your rhombus is correct, this will go and meet at C. Okay, so angular bisector of this angle A is nothing but the diagonal of a rhombus. You can prove it using congruence. Okay, so this will go and meet at C. Now this is the one which is equidistant from AB and AD, because any point on this is equidistant. If you measure like this, any point is equidistant from these 2 lines. Let's come to the second part of the question. So the first part we used one theorem. From A and C, we want the locus of the point which is always at the same distance, means we want the path of the point which is always at the same distance from point A and point C. Okay, what is the path of that point? Now the path of that point is the perpendicular bisector of the line AC. Now why, if I am drawing perpendicular bisector of this, you know what I am drawing? Because for a rhombus, property of a rhombus says that diagonals bisect each other at 90 degree. So if I am making perpendicular bisector here, in order to make a locus, it is nothing but the diagonal of the other diagonal, that is the diagonal BD, because diagonals are bisected always in all parallelograms, and in rhombus it is bisected at a 90 degree. So here we are going to get, Now how to draw this perpendicular bisector? So what I'll do, I'll erase it and I just, how will you construct? So you will have to construct the perpendicular bisector of this line, means you will have to fix your compass here at A, pull it up till more than half of the line. Okay, pull it up, pull up the pencil end till here and then make an arc here. With the same radius, make an arc below the line also. We are bisecting the line AC. With the same radius, don't touch your compass and change the radius. Fix it here, pull, and now don't pull it. You already have the radius. Cut the previous arc here and here. So basically, if you are bisecting this line, you fix it here, make an arc here, pull it, radius should be more than half of this line, and you fix it here and cut the previous arcs and join this. That is the perpendicular bisector of a line. Same thing I am doing for AC. Join these two. Okay. So if you join this intersection of arcs and this, you are supposed to get the perpendicular bisector. It will automatically come to 90 degree and it has to pass through the two other points of the rhombus. So the first answer, the locus is the diagonal AC, and for the second answer, the locus is the diagonal BD. Okay, so this is the next question. Construct angle AOB. Okay, so by now you all know how to construct an angle AOB, which is AOB. This is going to be a 60 degree. You have to, when they said construct, please construct. Okay, don't take the protractor and draw it. Mark a point equidistant from OA and OB such that its distance from another given line. Now you want mark a point equidistant from OA and OB. When they say this, first you will have to draw that. They are not, now look here, they are not looking for locus. Okay, they are looking for a point. They are looking for a point. But that point, if I draw the angular bisector here, because such that the point has to be equidistant from OA and OB, means I will have to draw the angular bisector here. Okay, draw it the way I taught you in the last sum. Okay, because all the points on this are going to be equidistant from this and this, such that its distance from another given line CD is 3 cm. Now there are infinite number of points here. We are talking about that point which is 3 cm from a given line. Okay, now what to do? So what we will do is, we will just make a random line. We'll just make a random line CD. We'll just draw a random line CD, straight line with our scale. Okay, this line CD. Now we need a point here which is going to be equidistant from this and this. Two conditions it has to obey. One thing, it has to be equidistant from this and this, and also it has to be 3 cm from the line CD. So what to do now? Distance from another given line CD is 3 cm. Now distance of the point from the line is CD. How will you know it? So what we will do is, at a distance of, let this line touch it. On this line we are going to make a parallel line. Okay, now when I have two parallel lines, if I say from CD, this line is at a distance 3 cm, that means at all points it is at 3 cm. At every point, if I measure, it is at 3 cm only. So what I am going to do now? Here I am going to draw, here I am going to make a line here. Let this cut wherever it wants, that is not important. I am going to make a 90 degree line here. How to make a 90 degree line? Like this. You know how to make. Okay. So with this type of construction, I am going to construct a 90 degree line. On this, now for this you will have to turn your notebook and do all that. Take a measurement of 3 cm. With your compass, take a measurement of 3 cm, and at this point again make a 90 degree like this. Okay. This line is going to go like this. Okay. So my 90 degree, when I join, it is going to go and like this. It should be parallel to this line. Okay, this line that you are drawing should be parallel. What I have actually done is this is 90, this also has to be 90, then co-interior angles will be supplementary, therefore these two lines will be parallel. Now the distance between these two parallel lines is a 3 centimeter. Okay, so if distance between these two lines is a 3 centimeter, I will have to look for that point on this line, which is where the parallel line cuts this angular bisector. Why? At this point it is following the first rule, which is saying that the point has to be equidistant from AB and AC, simply because it is on the angular bisector. And the second thing that I will be getting is any point here will always be at 3 centimeters from the line CD. Now don't take this itself has to be, maybe this line is not at 90 degree, no problem. If supposing this line is 90 degree, the measurement of this has to be 3 centimeter, because they are two parallel lines, we already know, at a distance of 3. Okay, so what I do, first thing I repeat. Okay, so if you have got confused, let me first make the angle 60 degree, construct, then draw the angular bisector, make any random line, it need not necessarily touch, there it has touched means it does not have to touch, make a 90 degree at any point, and then measure 3 centimeter, at this point make another 90 degree, and these two lines become parallel. When they become parallel, this is okay, these two lines become parallel, this is your point, the point of intersection of the other parallel line and the angular bisector is your required point. So we'll name that point as the point P. So my answer, if they will see the diagram only, but still you can write point of intersection of the parallel line, point of intersection of the parallel line to CD and the angular bisector. Okay, this, if you can write, if you get the time to write this, it is very good. Okay, because you are going for the boards. Okay, so this is my answer. So let's see the next question. This is ABC is an equilateral triangle of side 3.2. First, let us draw that, then we'll read the rest of the question. So how to draw an equilateral triangle? In order to draw an equilateral triangle, just draw 3.2 centimeter long line. Take a radius of 3.2. From here, mark an arc here. From here, same radius, mark an arc. You get your equilateral triangle. It is as simple as that. You don't have to make any 60 degree for this. Okay, so don't waste time. So this is my equilateral triangle which I have drawn using compass. Please don't take a scale and draw it. Okay, you'll get a better one with a compass, and if they have told equilateral triangle, it is better, even though they have not used the word construct, it is better to construct in the board exams. Now here everything is 3.2 centimeters. Find the points on AB and okay. So A, B, C, name them. Points on AB and AB produced, which are 2 centimeters from BC. Now why I took up this question is for this word. Okay, what is AB? AB is definitely this line, but AB produced is this. Okay, AB produced is this. Another thing, AB produced is not this. That is BA produced. Okay, so I hope you understand where lies the difference. So this is AB produced. This part of the line is AB produced. So you will also have to produce it. There should be no bends. Hold the scale and draw it. So AB produced, which are 2 centimeters from BC. Now they want points here and here, both of which, basically they want 2 points, both of which are 2 centimeters from BC. Now what to do? Okay, so 2 centimeters from BC, that means from the line, not from B, be careful. So if I want, what I will do is, I'll just draw a perpendicular here. You know how to draw a perpendicular by now. Yeah, okay, so this is perpendicular this side also. This side it is perpendicular, means the same line works for this other side. 2 centimeter is the distance. What I will do is, I'll take a 2 centimeter on my compass and mark a point here, 2 centimeter. Okay, let me say this is point P, this is point Q. At this point Q, I'll make another 90 degree. Okay, another line. Why I made 90 plus 90, 180, these two lines become parallel because co-interior angles are supplementary, then lines are parallel. So here, now this line I'll extend that side also, this side also. This is a parallel line. Same thing I'll do, I'll measure 2 centimeter, take a point R and then make a 90 degree here and I will extend that. Okay, and then it will come and touch here. Okay, so this point, this is let's say M and this point let's say N. These are the 2 points on AB, M is on AB and N is on AB produced, which are at a distance of 2 centimeter. Now you will see this and say this is not NB is not 2 centimeter. I am not talking about NB. When they say distance 2 centimeter, no, you have to extend this because the line is starts at infinity, goes till infinity. Okay, from infinity to infinity. So distance from this point will be measured like this. And since these two lines are parallel, at any point on this line the distance will be 2. Same thing here, if I draw a distance here, this will be 2 because okay, so distance of, same thing for this, from this point if I make a distance here, it will be 2 because it lies on the line which is parallel to this line. This also lies on the line which is parallel to this line. That is the reason. So you can say M and N, please mark them. It becomes easier for you and for the examiner. So M and N are the 2 points. You have to talk like that. So this question is a previous year question. This is a PYQ. Okay, construct angle 120 degree. Now 120 degree you have to construct. When they told construct means compass. Okay, ruler and compass only, no protractor. So you make this 120 degree angle which is A, B and C, and then AB and BC are 5 centimeters. Now how will you know whether it is 5? So once you have made the angle AB, BC, you from here you have to cut an arc here at 5 centimeter and name that as A. Here you have to cut an arc at C, name that at point as C. So this also becomes a 5 centimeter. So you have to take 5 centimeter in radius in your compass. From here cut an arc here, from here cut an arc there. Mark 2 points D and E which satisfy the condition that they are equidistant from BA and BC. Now again back to the theorem, 2 points which are equidistant from BA and BC. So locus of points which are equidistant from these two are the angular bisector, right? So lie on the angular bisector. So what we will do is, we will just take any 2 points here randomly are the points D and E which satisfy the condition that they are equidistant from BA and BC. Means you have to make the angular bisector first and then mark 2 points on it. So first make the angular bisector by bisecting the angle and then mark any 2 random angles. In the above figure, join AE and EC. So now you have to take a scale and as per the question you will have to join. Okay, AE and EC. Describe the figures A, B, C, D. A, B, C, D. Okay, they didn't say A, B, C, E. Okay, it is A, B, C, D. So A, B, C, D is what figure? A, B, C, D, if I join it here, so it becomes a quadrilateral. Okay, so you can just say this is a ABCD. ABCD is a quadrilateral. Okay, so it's okay even if the point D is slightly here. So you will get something like this, little bit bent inside. Even that is a quadrilateral. Okay, so don't worry whether it is a quadrilateral or not. So this point is a quadrilateral, and then another thing, if that can be told about this figure, is that it is a kite. So it is also a kite. Why? Because adjacent sides are equal in a kite. So this part equal to this, we can clearly see. Okay, why is it equal? Now because if this angle is equal to this angle, this part equal to this part, okay, this side equal to this side, this angle equal to this angle, then, and this is the equal side, common side, these two triangles are congruent. So by CPCD, these two parts are equal. And in a kite, you have these two equal, these two equal. So this forms a kite. Okay, next. The next part is BD. Now what is BD? BD is nothing but the, okay, they are asking in join AB and AC, describe the figures angular bisector. Angular bisector of BD is the angular bisector of angle ABC. Okay, let's come to the third part, ABE. Okay, ABE is which figure? This ABE is this one. It is a triangle. So ABE is just a triangle. That's it. Okay, so ABE is just a triangle. So it wasn't a very difficult sum. Only thing is drawing it and answering these questions was important. So here is my new question, again one PYQ. So construct the triangle whatever we have to do is given here. So you need a triangle here which is here ABC. This angle will be a 60 degree and BC will be 4.2. You know how to draw that, draw a triangle by now. And AB will be a 5 centimeter. Construct a circle of radius 2 centimeter which touches both the arms of ABC of triangle. So you need a circle here, okay, which will touch AB and it will touch BC. How will you know that? Okay, so here we will a circle of radius 2 centimeter. What we have to do is, this is little difficult, okay, so mark this as an important question because we can't think like this in the examination. What we have to do is, we'll just make somewhere one perpendicular to this line. Okay, how? This way, you know to make it now. And we will mark 2 centimeter over here. At this point, we'll make another 90 degree. Why we are doing all this is because we need a line which is parallel to BC. Okay, let that line be MN, which is, this line MN is parallel to this. Okay, the distance between these two lines is 2 centimeter. We know it. Now, we will also draw the angular bisector of this. Okay, we'll draw the angular bisector of this. The point where they intersect, that is the point which I make as the center. So the point where the angular bisector meets the parallel line is the center. You can mark it as O and now take a radius of 2 centimeter and draw a circle. So here when you take a radius of 2 centimeter, you will see that you are automatically getting a circle which is touching this and touching this. Now why did it happen? Okay, we know that any point on this line is at 2 centimeter because this line is parallel to this. So if I make a perpendicular from here, because this perpendicular, okay, this perpendicular and this perpendicular has to be equal because this point is on the angular bisector. Okay, and if I make a perpendicular from here and a perpendicular from on this point, on this line, on the line AB and on the line BC, they will be equal. If this is 2 because of parallel line, this will also be 2 because of angular bisector. Do you follow? Okay, because it is a point on the angular bisector. Therefore, they are both going to be 2 and 2, so the line will not cross through the circle but it will touch the circle. Okay, so another thing, if it is a 90 degree, the line actually forms a tangent which shows that it is not going to cross the circle, it will just touch the circle at, let me name it as P and Q. Okay, so it is the point of intersection. How do you get the circle? You get the point of intersection of the angular bisector and the parallel line. So two constructions here, first a parallel line, then angular bisector, point of intersection, take a radius of 2 and draw the circle. Your circle is going to come perfect. So here the first part of the question says, make a triangle in which angle ABC is 120. So what we will do is, angle ABC, this has to be 120, make an 120 degree angle, construct. Okay, they said construct using ruler and compass only. From this is point B. take AB as 3.4. In your compass, you'll take a radius of 3.5 and then cut an arc here. Take a radius of 6 centimeter, cut an arc here. So you get your triangle. Okay. In this triangle, now the second part, triangle done. Draw a circle with BC as diameter. When they want BC as, I'm sorry, this is A. When they want BC as diameter, then you have to, when BC is the diameter, then you have to get the perpendicular bisector. Only then the two radius will be equal, right? So how to get a perpendicular bisector, that you know by now. You have to make an arc here and make an arc here, and like this you get the perpendicular bisector. Okay, so you have got the midpoint. Now you will draw a circle taking this, mark this as O, taking OP as radius, measure it as the radius, and then draw a circle. Okay, you will draw a circle like this. Okay, you will construct a circle. Now they are saying, so you have to mark a point P on the circumference of this circle, which is equidistant from AB and BC, measure angle PCP. So you want a point on this circumference. So many conditions, you have to get it on the circumference. It has to be equidistant from AB and BC. If it has to be equidistant from AB and BC, you will have to draw the angular bisector. Okay, you'll have to draw the angular bisector again, and then the point where the angular bisector and the circumference has in common, that is your required point P. Okay, so that is your required point P. Now they are saying get angle BCP. That means if I join this, they want this angle. Okay, now this point satisfies, it is equidistant from AB and BC because it lies on the angular bisector and also it lies on the circumference. So all conditions are fulfilled. They want this angle. Now know one thing, angle in a semicircle is 90 according to your circle theorems. This angular bisector means this is 60 degree. You have bisected that 120 degree angle. So this is 60 degree. Therefore this angle should come. This is a rough diagram, but when you actually draw it, it should come to either 31 or 29 like that. 1 degree this way, that way, they agree. Okay, they will not you will not lose marks, because in practicality, maybe your angular bisector is little bit here and there, maybe your 120 degree is not exactly 120. For all that, you might not get this as 30. If you get 29 or if you get 31, then you get the marks for that. Okay, so don't worry if you get a 29 or a 31. Okay, so that much 1 degree they will give you a concession. Construct a triangle. This is a new question. Construct a triangle. Now all the three sides are given. Whenever all the three sides are given, it is very easy. Draw AB, which is 5.5 long line, and over here, take a radius of 3.4 from B and mark an arc here. Again, take a radius of 4.9 from A and mark it here. This point becomes your point C. Okay, this is your point C. Join, you get your triangle. Easiest triangle possible in construction of triangles. Now, locus of the points equidistant from A and C. Locus of the points equidistant from A and from C. Okay. So if we want locus of the point equidistant from A and C, we have to draw the perpendicular. They didn't say the lines, they said the points. So we have to make the perpendicular bisector by that arc method. Okay, we got the locus. And that is the second part. A circle touching AB at A. It touches AB at A and passing through C. Now we have to draw a circle which will, firstly, this is a perpendicular bisector, means this part is equal to this. Okay, so we can use it as the diameter. So touching AB at A, okay, and passing through C. So the circle has to touch AB at A and it has to pass through C. Now since, mark the word touching, okay, this is not crossing. Touching and passing are two different things. This is where people do wrong. What they will do is they'll put the center here and they'll make a circle passing through this. No, we don't want it. Touching here means it has to be a tangent at, at this point it has to be a tangent. Here it will just cross through. Okay, what to do? If it is a tangent, your circle has to be at 90 degrees. Okay, the for a tangent, the radius has to come at 90 degrees at this point. So you can't take this point because this is not at 90 degrees. What you have to do is you will have to draw at this point you have to make a 90-degree line, and this 90-degree line, okay, this 90-degree line is going to touch this somewhere. Now if you take this as the center, okay, then it is going to touch because this line is at 90 degrees to this. Remember, in a circle the radius is always at 90 degrees to the tangent. That's exactly what we are doing. So now take this as the center because this will act, let me mark it as the point P. This P will act as your radius. Okay, take this much as the radius, measure this as the radius and make a circle. It will pass through C, but it will be touching this and it will be passing through C. Okay, it will be passing through C. It is not necessary that it will make this line is going to make a 90-degree there, because they said passing through. So this line, even if you join, it will not make a 90-degree. Don't bother about, because it is just going to pass through C, but here it is going to touch. Now why this is happening? You will say that if this side it is a tangent, then that side also it has to be a tangent. No, that side it does not have to be a tangent, because length of this and length of this, it is not exactly a kite or something. Okay, so the length of this is 5.5 and BC is a 3.4. So this length is varying. Okay, had it been 5.5, then it would have been a tangent that side also at C. But because it is 3.4, these are unequal sides, so you will just get an intersection there, not a tangent. Okay. So that was loci. This was the last of the PYQs. I hope you liked the video. If you have liked the video, please subscribe it, because lots of more videos, lots of PYQs and sample paper solutions are going to come up till February end, till your exams, not till February end, but till your exams is going to be uploaded. Thanks all of you. Bye then.